Hello, dear student. Today we continue to learn the introduction. Today we will learn the mechanisms of heat transfer. The mechanism of heat transfer means how the heat is transferred. In general, there are three basic heat transfer mechanisms. They are heat conduction, heat convection, and radiation. Heat can flow by conduction, convection, and or radiation, respectively. Sometimes two or three mechanisms can occur simultaneously. Okay, first, let's look at conduction. What is conduction? It can flow unaccompanied by any observable motion of matter if a temperature gradient exists in a continuous substance. This is the definition of conduction. It means in the conduction, there is no any observable motion of matter. This is the characteristic of conduction. Conduction may result from different causes. For example, in metals, small conductivity results from the motion of free electrons. Because there are many free electrons in metals, so the motion of free electrons is the reason of conduction. So there is a close correspondence between thermal and the electrical conductivity. In solids that are poor conductors of electricity, for example, wood, plastic, and glass, and so on, and most liquids, thermal conductivity results from the momentum transfer between adjacent vibrating molecules or atoms. In gases, conduction occurs by the random motion of molecules. Okay, next, I will introduce you a new concept, pure conduction. What is a pure conduction? It means it is a conduction without the observable motion of matter. There are many examples of pure conduction. For example, heat flow in opaque solids, such as the brick wall of a furnace or the metal wall of a heat exchanger tube. Let's look at these graphs. The first graph is a flat wall conduction. The red color denotes the furnace wall. The gray color denotes the brick wall. The brick wall is outside the furnace wall. The function of the brick wall is to prevent the heat in the furnace from losing to the environment. So it is an insulation. Because the temperature of the furnace wall is higher than that of the brick wall. So the heat is transferred from the furnace to the brick wall. The red arrow is the direction of heat flow. This heat transfer process is in solids. It is a pure conduction. In this process, there is no observable motion of matter. Okay, let's look at the other example. In the right graph, it is a metal tube. It is a heat exchanger tube. The temperature inside the tube is higher than that outside the tube. So the heat will be transferred from the inside to the outside along the radius direction. This is the direction of heat flow. It is a radius direction. In this heat transfer process, the heat transfer in the tube wall is a pure conduction because it is a heat transfer without observable motion of matter. It is a cylinder conduction, cylinder wall conduction. Okay, that's the contents of today's class. Thank you.